So after having a discussion about the branch circuits, we will now discuss about the basic of electrical layout. So under this main topic, we have a learning outcome that you will now learn how to discuss the sample building electrical system for residential and commercial buildings. So after this video, I will attach some of the instructional uh, reading reading on some of my projects. Electrical drawings plays an important role in electrical installation works. So everything in construction works, we need to have a drawing or plan. So as they convey information about connection of various devices and equipment with mains. So the information on drawings provides the complete design or plan of electrical installation. It helps to assemble the various equipment. Before we proceed on how to read or familiar the electrical layout, these are the main sheets components. The first one is the floor plan. You need the electrical specifications, symbols, and the site development, the lighting layout, the power layout, your computation and schedule of loads, the riser diagram, and the very important part of the electrical plan is the short circuit and voltage drop calculation. In parts of an electrical wiring plan, you need a pure floor plan, okay, to analyze where your lighting fixtures, your wiring devices will be located on its plan of a room or floor of a building. So assume that this is a residential and its floor plan. Okay. Now, the notes and specification and miscellaneous. Some of the sheets, the miscellaneous belong to the last sheet. But for me, I put the electrical notes and specification, the miscellaneous, which is panel board, mounting detail, service entrance schematic detail, and the legend symbols are located at the first page. Okay? Parts of an electrical wiring plan, don't forget the title block, because the title block or the nameplate indicates the name and location of the proposed installation, name and address of the owner, name and signature or dry seal of master electrician or electrical engineer. But take note, this is wrong because in the electrical plan or plans that submitted in the OBO or the office of the building official and the city engineers, there's no signature and dry seal for the master electrician or electrical engineer. Take note, it needs a name and signature for professional electrical engineer. So this is not correct, because as we practice in our RA 7920 or the law of electrical engineers or law of electrical engineering, it must be signed and sealed by professional electrical engineer. The printed name of the owner, then initial of the draftsman, and the data when drawing was done. So that is why the initial of the draftsman, that is the code of the registered electrical engineer who designed the plan. Now let's go proceed to the title block. So as you can see on the title block, you can see the name of the professional electrical engineer, its data here, its registration number for the PRC, professional tax receipt or the PTR number. Every year this is updated, while the PRC is updated for every 3 years. Then the TIN number or the BIR TIN. The seal of the professional electrical engineer will be sealed here. The project title, the owner or the name, the sheet content or the name of the sheet, Then the drafting, who drafts. So it is me, JPL, that is my code name or my initials, then REERN. So date, then design and check, okay, by the PEE. Then approve and revisions. There's a slot here. So what is the purpose of the drawing? That is for bidding, building permit, and construction, and everything. So sheet number E, say E represents the electrical, and sheet number 1 out of 4 sheets. Now the lighting layout. So this is the lighting layout. So comprised of the ground floor, second floor. Sometimes there's a ground floor only in the one sheet, but for me, I put 2 floors here, the ground floor and the second floor, together with its the legend or symbols as guide for who are guide for a person who will read the electrical plan. So the components of ground floor lighting layout, take note on this part. As you can see, I use the line, which is a curved line or a spline function in the AutoCAD, or arc. It's up to you, but you need, for electrical layout, electrical connection, it must be curved. Okay. Then this is for circuit 1. The home run. So as you can, let's go to the electrical symbol. This is what they call home run. Oh, I forgot to put the home run here. Okay, this is the circuit home run, where the arrowhead and its number indicated. Panel board and the smoke sensor. So let's go to the ground floor layout. So you can see the arrowhead is pointing out to the location of the panel board. Okay. Then circuit number 2 to the panel board. So this is the zoom one. So for this example, it's better to remove the fixtures or the furnitures to elaborate or to clearly see the lighting fixtures, which is what type of fixtures you use. It is just a pin light or recessed light. For power layout, so there's a ground floor power layout together with the legend symbols here, or electrical symbols. Then let's proceed to the circuiting. So before you proceed to the numbering of the circuiting in the power layout, I just want you to inform that before you proceed to the power layout, you need to finish out the numbering on the lighting. As you can see, in ground floor, let's wait. In ground floor, starts at 1, 2, 3, then 4. So this is just 2-floor residential. So let's go. So we stop on the circuit number 4, and when in the power layout, from 4 it started to 5, 6, 7, 8, 9, and 10. Then 11, 12, and 13. So overall, you have 13 branch circuits for this two-story residential building. Okay, so for layouting the power layout, it is not a curved line anymore. It is just a straight line. As I mentioned earlier, that ACU belongs to the individual branch circuit. That is why ACU has individual branch circuits. There is no other connection. That is circuit number 11. While these 2, 1, 2, 1, 2, 3, 4. Okay, 4 convenience outlet connected in the circuit number 12. So straight line only. Okay, ACU separate, circuit number 13. So that is the difference between the lighting and power layout. For lighting, you need to use the curved line. For power, use the straight line. Let's go back again to the lighting layout. As you can see, there is no switching here. But in the next video that I will attach, I will give you a guide on how to make a switching diagram for lighting layout. This is the schedule of loads. Okay. For schedule of loads, we have 13 branch circuit based on the floor plan. Then I give 3 spares just for a future purposes. So the computation is we just add all lights 11, then assuming that there's a corresponding 11 times divided by 1500 watts, just to know what value of watts every lighting or LED fixture. So 1500 divided by 230 volts. Remember that watts is a power. Power is equal to voltage times current. So to get the current, watts over volts, that is your ampere, 6.52. Okay. Then limit for lighting, we use 20 ampere trip. For aircon, we use 30 ampere trip and convenience outlet. Okay. Ref is 30 ampere trip. Okay, this is just basic or the minimum sizes of wires for residential. So minimum size of breaker, 20 for lighting, outlets, and aircon, that is 30 ampere trip. And for wire size, the smaller one is 3.5. Since we are updating our Philippine Electrical Code, we are not now using the 2.0 mm squared. 2.0 mm squared represents the ground wire. Then the pipe size. So this is the minimum. So this is the load computation. Size of the conductor. So this is to know what will be your main wire that you will use. Size of circuit breaker, the main breaker. Then the size of transformer, where you need to apply it in the double line. Okay, there's a load computation that you need to crisscross if your schedule of loads and the load computation is correct. Then the next one is the riser diagram. The riser diagram will give you an outline of your circuit, and this may serve your guide if you have installed panel board. So you will know that the left side is an odd, at the right side is an even branch circuit. So circuit number 1 is lighting, circuit number 2 is lighting, and so forth. So this will give you for some contractors, they printed this and stick it on the cover of the panel board as your guide, okay, for safety and maintenance. So this is, you can see that there's a 222 mm squared. This is the main feeder, main breaker, 100 ampere trip, your service entrance, kilowatt hour meter, then your transformer. Then the next one is sometimes the OBO or the city engineers also required now the riser diagram layout. This is a sheet from my commercial project, so that is why there's a 4 panel boards connected in the electric gutter box. So this illustration is similar on the picture that I've showed earlier. Your commercial buildings with with many meters. So this is the illustration. Then in this right side, this is the voltage drop, where PEs and registered electrical engineers can solve this. It cannot be copied, it cannot be copy paste, but this is every project and every design or any kind of buildings, it must undergo with a computation or design analysis. Okay, then these are the electrical symbols, common electrical symbols that we use for electrical engineering.